Hello, everyone, and welcome back to our study for deep learning techniques. As I explained in another video, choosing a fast optimizer can hugely improve the process of training. Uh, Gradient descent is just one optimizer which can be used for training. Here I have listed some other optimizers that we have in Keras, and we can use them for optimizing. For example, momentum optimization, AutoGrad, RMSprop, Adam. These are some optimizers that we have in Keras. I would like to add also that these optimizers have some tricky math behind them, but you do not need to really worry about those math concepts. Because if you look at the help of Keras, as you can see, all of these optimizers have been listed here. And SGD, for example, Stochastic Gradient Descent, RMSprop is one optimizer that we had on the slide. Adam, for example, is another that we had on the slide. And you have some examples. I will explain how these codes can be done on another video. But in this video, I just want to say that, for example, if you want to use Adam, as you can see, this is just one line of the code. And if you want to use other optimizers, say, for example, SGD or gradient descent or any other optimizer, you just need to change this Adam. Also, I would like to explain a little bit about the concept of the learning rate. Finding the good learning rate can be tricky. If you set it way too high, training may actually diverge. And if you set this too slow to too low, training will eventually converge to the optimum, but it will take a very long time. Then you can see that you have a very hard situation, because if you choose learning rate which is too high, you may diverge and never reach the optimum value. And if you choose the learning rate which is too low, then you can make the process of learning too slow. If you consider that slightly too high, it will make progress very quickly at first, but it will end up dancing around the optimum value and never really settle down to the optimal value. If you have a limited computing budget, you may have to interrupt training before it has converged properly, yielding a suboptimal solution. Then, as you can see, it seems using a constant value for learning rate sometimes is not good, because at the beginning, we do not know if the learning rate that we are choosing as the constant value is really the best value that we can choose. Therefore, people prefer to use a variable of learning rates. One approach is to start with a large learning rate and divide it by 3 until training algorithm stop diverging. In this case, as you can see, by 3 is just one example. By using another numbers, by dividing learning rate, which is considered at the beginning very high number, by a fixed number, you are making the learning rate not constant. And as you can see, learning rate is changing through the process of training. You will not be too far from optimal learning rate, which will learn quickly and converge to a good solution. However, you can do better than constant learning rate if you start with a high learning rate and reduce it once it stops making fast progress. You can reach a good solution faster than with the optimal constant learning rate. As you can see, dividing by 3 is one example. We will see other examples. For those, we can consider a learning rate which is not constant. Here we have this example of decaying learning rate, because this process that you start by a high learning rate and make it smaller is called the decaying learning rate. You can see one example on the Keras help. In this case, as you can see, we are starting the learning rate, and in this case, as you can see, we are making learning rate smaller and smaller. In another video, I will explain about this code. I think it is good time to stop. Thank you.